This is a virtual plant tour. The plant you'll visit is the highly advanced waste-to-energy plant in Meath County in Ireland. The plant is Ireland's first waste-to-energy plant, and it's able to burn 27.6 tonnes of untreated household waste per hour. The energy from the waste is recovered and provided back as electricity to 20,000 households. The entire project took just 31 months to complete, from project start to handover to the customer. Our customer is Indeva in Belgium, and our scope is the fuel feeding system, the combustion grate, the boiler, the combustion control, and the Denox SNCR systems. Press any of the technologies marked in red to learn more, or click to get the full tour of the plant. The Meath plant is able to burn 27.6 tonnes of waste per hour. This large bunker can contain enough waste fuel to keep the plant running for 4 straight days. The plant is operated by 2 cranes. One is used for feeding the plant. The other is used for mixing the waste in the bunker area. This second crane is also used as backup. For fuel feeding onto the grate, we use a ram-type feeding pusher. This is important because with the correct feeding, we can control the combustion and energy production. The fuel rate is controlled by our automatic combustion control system. The feed chute is water-cooled and made of strong steel plates. The chute is equipped with 2 hydraulic dampers that ensure plant safety during startup and shutdown. The Meath waste-to-energy plant is equipped with Dynagrate, the most advanced combustion grate on the market. Dynagrate is available in both water-cooled and air-cooled designs. The water-cooled Dynagrate is suitable for high-caloric waste with heating values of up to 25 megajoules per kilogram. It has a smart integrated cooling system in the shafts, which means that there are no pipes or hoses under the grate. This minimizes operational problems. It also has a unique design, as there's no contact between the grate bars. This ensures minimal impact of mechanical forces and limits wear and tear. A unique feature is that it can process waste containing large amounts of metals and still operate efficiently. This provides a significant financial benefit. There are 4 separate combustion sections in each lane, making it possible to control the speed and excess air in each of them individually. For a large combustion grate like Meath County with 2 lanes, the plant has control of a total of 8 individual grate sections. Unlike many of our competitors, our waste-to-energy plants are equipped with water-cooled wear zones. The water-cooled wear zone ensures long life of the plant and minimizes the downtime from unplanned stoppages. The maintenance cost is extremely low compared to refractory. What's more, the higher heat uptake will result in a more compact boiler. Finally, the water-cooled wear zone is part of the boiler circulation system and doesn't require extra process equipment. Under the grate, we have the primary air hoppers, which also collect the grate shiftings. The volume of shiftings from a Dynagrate is remarkably low and less than 1% of the input. The grate shifting is transported in a vibrating conveyor and is mixed with the bottom ash. The bottom ash discharger is a ram-type conveyor. Our many years of experience in handling bottom ash gives us a unique ability to recover a major part of the metals. The bottom ash is a valuable resource. The remaining ferrous and non-ferrous metals in the waste are extracted from the bottom ash and can be recycled into new valuable products, such as bicycles, window frames, or aluminium castings for the automotive industry. Other remaining minerals are used as secondary aggregates. In many European countries, these secondary aggregates are used in building products or in road construction. The combustion air is divided into primary and secondary air. The primary air goes to the combustion grate and the secondary air goes to the furnace and the boiler. The primary air is taken from the bunker area and the top of the boiler building. The combustion air intake ensures a constant low pressure in the bunker area. The air that's drawn into the building is fed through the furnace where it's combusted, destroying odours. This means that there's no odour from the waste and therefore no smell in the neighbourhood. The combustion air fan provides the flow into the air manifold. In order to control the airflow and each individual combustion section, the flow will be measured by the Venturi system. The primary air is distributed under the grate into the individual combustion sections. In order to enhance the combustion process, the primary air is preheated up to 150 degrees Celsius. Our secondary air consists of two subsystems. The secondary air nozzles, which are in the ceiling of the furnace, are used to enhance the combustion process and stabilize the ignition zone of the waste that enters the furnace. This gives a better combustion and burnout. The other part of the secondary air is located in the inlet to the first boiler pass. The system is designed with our CFD tool under the trademark Volumix. All our boilers are designed by our CFD specialists in order to achieve the best flow and temperature conditions. In order to protect the radiant part of the boiler, we use Inconel, which protects against corrosion. Our Inconel cladding is based on the latest CMT cold metal transfer technology, ensuring high quality and a long lifetime. Our iron content in the Inconel is very low, typically less than 3%. In order to ensure high availability, we use our Volund online boiler washing system. The boiler washer is fully automatic and able to clean radiant passes quite efficiently. Therefore, we can control the inlet temperature to the convection part and reduce the risk of corrosion. Our multi-pass boiler has 3 empty radiant passes. In this section of the boiler, the dominant heat transfer is by thermal radiation. At the second or third pass of the boiler, we add extra surface, like baffle walls, to increase the heat uptake. When leaving the radiant boiler, the temperature is typically 625 degrees Celsius. The convection part consists of our superheater section followed by an economizer. Both of the sections can be either horizontal or vertical, depending upon the layout of the plant. Here at the Meath County Waste-to-Energy plant, the convection part is horizontal and the economizer vertical. The superheater section is made up of a number of tube bundles in which steam is superheated before it goes to the steam turbine. The steam turbine produces electricity for the community. After leaving the turbine, the steam goes to an air-cooled condenser and will return to the boiler as feed water. The superheater section is cleaned by pneumatic wrapping devices. In order to avoid corrosion in the final superheater section, we've developed a special configuration of the bundles. It's just one of the many innovations resulting from our years of experience. The economizer consists of thousands of water tubes that cool down the flue gas and thereby recover as much energy as possible. We're using steam soothe blowers for online cleaning of the economizer. We're able to precisely control the boiler flue gas outlet temperature to within just a few degrees Celsius. This results in very high efficiency. After the boiler and economizer section, we move to the plant's flue gas treatment section. In Europe, waste-to-energy plants have the lowest emission limits of all industrial sectors. The flue gas is cleaned with an advanced cleaning system before it leaves the chimney. This system consists of 2 parts: a semi-dry reactor, and a baghouse filter. For this particular plant, flue gas cleaning wasn't part of our scope, but naturally we can provide advanced flue gas cleaning too. Our subsidiary, Jutterwerken Milieu, is a world leader in flue gas cleaning technologies and famous for its patented Adiox system. This has been an introduction to vital parts of the sophisticated hardware of a waste-to-energy plant. In order to connect and control this advanced plant, you'll need a superior combustion control system too. At B&W Volund, we provide a system that guarantees just that, with a steam variation within ±5%. The Meath County plant is the first waste-to-energy plant in Ireland, and 20,000 households in Meath County are supplied with electricity generated from household waste. If you'd like to see this plant in person or visit another waste-to-energy plant, please contact our sales department. For further information, please visit our website at volund.dk.